you by thesis123.com. I learn and teach online.
Here's the next question, number 40. The incremental costs in rupees per megawatt hour of operating two generating units are functions of their respective powers P1 and P2 in megawatts and are given by dC1 by dP1 equals 0.2 P1 plus 50, dC2 by dP2 equals 0.24 P2 plus 40, where P1 lies between 20 megawatts to 150 megawatts and P2 lies from 20 megawatts to 150 megawatts. For a certain load demand, P1 and P2 have been chosen such that dC1 by dP1 equals 76 rupees per megawatt hour and dC2 by dP2 equals 68.8 rupees per megawatt hour. If the generations are rescheduled to minimize the total cost, then P2 is dash. Okay. Now, for the first step, let's utilize the incremental cost given. We have two equations here. dC1 by dP1 equals 0.2 P1 plus 50. dC2 by dP2 equals 0.24 P2 plus 40. And we also have the amounts given here for rupees per megawatt hour. Let's equate both of these pairs of equations and find out the values of P1 and P2. That's the first step. I'll write it down here. So we have dC1 by dP1 equals 0.2 P1 plus 50 and the value of dC1 by dP1 is given as 76 rupees per megawatt hour. Now we can equate both these values. Let's see here, 0.2 P1 plus 50 equals 76. Now using this, solving this, we can find out what P1 is. So once you solve, you should get a value of P1 equals to 130 megawatts. Similarly, we do the same thing for dC2 by dP2. We have the equation given as 0.24 P2 plus 40 and the value of dC2 by dP2 is given as 68.8 rupees per megawatt hour. Now we equate the two. 0.24 P2 plus 40 equals 68.8. Now solving this, you should get a value of P2 as 120 megawatt. Since we have the values of P1 and P2, let's check what the total value comes to. P1 plus P2, if we add them, we get 250 megawatt. Now let's call this equation 1. We'll call this equation 1. Now the question says that the generating units have been rescheduled, right? If the generations are rescheduled to minimize the total cost, do you see the very last statement there? The generations are rescheduled to minimize the total cost. Now in order to minimize the total cost, we have to equate the incremental cost equations given to us. To minimize the total cost, we have to equate the incremental cost equations. What are they? This equation here and this equation here. Now we have to equate both these to find out an equation in terms of P1 and P2. Let's do that. 0.2 P1 plus 50 equals 0.24 P2 plus 40. Okay, bring the variables to one side. You should get 0.2 P1 minus 0.24 P2 equals minus 10. Let's call this equation 2. Now the total power is 250 megawatts, and in order to minimize the total cost, we have obtained a second equation. So let's solve both this 1 and 2. So if we solve both these equations, we should get the values of P1 and P2. Okay, so here's another sheet of paper. Now I'll leave the solving to you since they are equations in two variables. You can either solve it manually by using one of the many methods. Since that's basic algebra, I'll leave that part to you. Now you should get a value of P1 as 113.636 megawatts and P2 136.36 megawatts. Now the question asks you for P2 alone, so the value that you should write down is 136.36 megawatts. 136.36. So this is the entire solution, and I hope this has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.